Let's follow the same steps on my variation column. So we have just seen that the gene column was relevant. Now we're going to work on the variation column and see that whether my variation column is going to be relevant here also or not. So in order to do that, again, we are going to look at that how this distribution looks like. So we can notice that we do have some 1936 unique values, and the distribution looks like this, that we do have training mutation, this, but if you look at it, apart from these four values, almost the remaining values have the values occurring less than 5 in number, right? So maybe we can see the same thing during when we are going to build our basically graphs as well. So let's see whether that is happening or not. So let's go down and see this part. And yes, we are right. So you can see that there's a spike here. But after that, the values are moving like this. But in fact, if you look at it here, 80% of the data may be falling till 1500, right? So because the distribution for the remaining points are very less, maybe they are just talking less than 4, 5, this number, right? So that's what is happening here. Now let's go ahead and see a few more things. Now for this portion also, we're gonna create the one hot encoder and response encoding. So for this, when we did the one hot encoder for my basically all the data set, which includes my training data, testing data, and cross validation data, and when we created this, we got 1967 column. You can see that it's huge, right? Now then after that, I'm gonna again apply my response encoding, and again I'm gonna call the same function which we have created above, and this is gonna return me only 9 particular columns for my variation. So I hope now I no need to explain in detail about what is happening here. Then after that, we're gonna build our model in the same way, just keeping my variation column. And again, the same technique, I'm gonna use one hot encoder, I'm gonna use SGD classifier, same L2 penalty, same logistic regression. I'm gonna run it for a different value of alpha, and when I'm going to run it, I'm gonna get this output. Again, I will look at the minimum value out of it. We will do a plotting of this part, and once we do the plotting, we will get the best alpha, and we will start generating the log loss for each. Now let's look at the log loss. If you look at the log loss, for my best value of alpha, my log loss for test, which is more important for me, is around 1.70, which is again lesser if I compare with respect to my random model. So definitely it is a good model. It's a good feature to look at. It's not a bad feature. So we may want to even look at this feature and will not ignore it. So this is also one way to look at if any of your column is important for the final output. But if I look at the stability point of view, then my percentage have gone down. So my test data have only 10.97% of overriding here, and for my cross validation I do have 11.4% of this. So this is a problem, right? So if you look at it, definitely this is low. So looks like this feature is not very stable, but at the same time, since my log loss is pretty low, if it would have been kind of nearby to my basically or exactly kind of nearby to somewhere random model, I would have kind of ignored this particular column. I would have not considered it my final model which we are going to create. But in this case, maybe we are okay to kind of ignore that, because definitely if we look at this particular scenario, we though we have a less stable feature in terms of very less overlap is happening, but let's give priority to log loss and decide to keep this column for our case. So this is how you can look at this. Now after that, we have to look at text column. We will do that in the next lecture.